Title: What would happen if an asteroid hit Earth? A detailed look at 6 impact scenarios. Introduction. The possibility of an asteroid striking Earth has long captivated scientists and the public alike. But what would actually happen if an asteroid were to collide with our planet? To explore this, we'll run a simulation of 6 different asteroid impacts at varying speeds, from 10 kilometers per second to 60 kilometers per second, and examine their effects on Earth's surface, atmosphere, and humanity. Asteroid versus Earth, simulating 6 impact scenarios. In this simulation, we analyze 6 asteroid impacts with velocities of 10, 20, 30, 40, 50, and 60 kilometers per second. These scenarios will show us how varying speeds influence the scale of devastation, providing a clearer understanding of what each impact would look like. 1. Impact speeds and the collision process, 10 kilometers per second. At this slower velocity relative to cosmic standards, the asteroid would still create a massive explosion, forming a large crater and generating significant destruction. The impact area would be localized, but the energy released could still devastate cities within several hundred kilometers. 20 kilometers per second. Doubling the speed increases the destruction exponentially. The impact would throw up more debris into the atmosphere and cause a wider crater. At this speed, the asteroid would unleash an energy equivalent to millions of nuclear bombs, vaporizing everything in its immediate vicinity. Shock waves would be felt across continents. This speed would result in an even deeper and broader crater. The atmosphere would be filled with ejecta, darkening the sky and setting the stage for long-term climate change. 50 kilometers per second. The energy released at this velocity would trigger massive environmental shifts, including supervolcanoes and worldwide earthquakes. 60 kilometers per second, the most catastrophic scenario, an asteroid at this speed would generate global seismic events, a shock wave felt across the entire planet, and an air blast that could cause irreparable damage. Crater formation and destruction. With each increasing speed, the craters formed would grow larger and more destructive. In the most intense scenarios, these craters could span several kilometers in diameter and penetrate deep into Earth's crust. The destruction of cities and structures would be complete, leaving only a barren wasteland where a metropolis once stood. Furthermore, the impact would eject billions of tons of rock and dust into the atmosphere, causing massive disruption to global ecosystems. TAP energy release and shock waves. The energy released by each impact would dwarf even the most powerful nuclear weapons. For example, an asteroid traveling at 60 kilometers per second could release more energy than the largest earthquakes ever recorded, resulting in a shockwave that travels across the Earth's surface. Buildings would collapse, forests would flatten, and anything in the path of the air blast could be instantly destroyed. The ground shock would fracture the Earth's crust, triggering secondary disasters such as volcanic eruptions and widespread earthquakes. Environmental effects. In addition to immediate destruction, the aftermath of an asteroid impact would have long-lasting environmental consequences. Climate change. Ejecta thrown into the atmosphere would block sunlight, creating a nuclear winter effect. Temperatures could drop globally, threatening agriculture and food supplies. Volcanic eruptions. The seismic shock from the impact could trigger dormant volcanoes worldwide, releasing additional ash and gases into the atmosphere, further exacerbating climate change. Earthquakes. The ground shock could cause significant tectonic disturbances, resulting in earthquakes around the globe. Perhaps the most devastating consequence would be the human toll. The loss of life in the immediate impact zone would be enormous, with entire cities wiped off the map. Those outside the blast radius would still feel the effects through food shortages, economic collapse, and societal upheaval. Governments would face immense challenges in managing the widespread destruction of infrastructure and the displacement of millions of people. The economic impact would be catastrophic. Global markets would crash, industries would halt, and international trade would be paralyzed as the world attempted to recover from the physical and environmental damage caused by the asteroid. Conclusion. The results of the simulation are clear. An asteroid impact, regardless of its speed, would be catastrophic for life on Earth. From widespread destruction and loss of life to long-term environmental consequences, The effects would be felt for decades, if not centuries. Understanding the potential devastation emphasizes the importance of asteroid detection and deflection efforts, which could one day prevent such a global disaster from becoming reality.